Now, how this virtual memory works actually? The whole process is actually to implement the virtual memory, right? So how it is working in modern world, virtual memory has been quite common these days. In this scheme, whenever some page need to be loaded into the main memory for the execution and memory is not available for these many pages, then in that case, instead of stopping the page from entering into the main memory, operating system search for the RAM area that is least used in the recent time, or that is not referred or copy that into the secondary memory to make the space for the new page into the main memory. So the same thing is happening, right? So if there is no space available, so A will be replaced and will be copied into the secondary memory. When there is a free space, then the other page will be loaded into here. So the same thing is telling by this particular sentence. Since all these procedure happen automatically, therefore it make computer feel like it is having the unlimited RAM or unlimited memory. So all these processes automatically, that's why there is a illusion to the user or the programmer that I have enough main memory to execute that particular process. How we can implement the virtual memory? We can implement it using the concept of demand paging or demand segmentation. So what is a demand paging? Demand paging is a popular method of virtual memory management. In demand paging, the page of a process which are least used get stored into the secondary memory. So whenever we see that there is a process which is of least use, we put into the secondary memory. A page is copied into the main memory when a demand is made or page fault occur. There are various page replacement algorithms which are used to determine the page which will be replaced. It will be discussed later in this particular lecture. So what it says that a page is occupied into the main memory when a demand is made or page fault occur. There is a various page. So we have the various page replacement policy that we'll use. So ultimately the thing is that we have this particular main memory or physical memory or RAM. Okay, this is your RAM. So in the RAM is divided into number of frames. And if the number of frames, definitely this physical address space is less than the virtual address space. So let's say page number 1, 2, 3, and 4 are there. If we require 5, so what we do? We have to replace any of the page and put it into the secondary memory, and then we'll have the space for 5. So let's say 1 will be coming here. All the copies are here, but we'll replace only those pages which are modified. Otherwise, we just remove it. We just remove it and put 5 here. So this removing and replacing will be done by page replacement algorithm or page replacement policies that we'll use later on. Now to implement the demand paging, we have two type of demand paging. One is called pure demand paging, another is called prefetched demand paging. So let's see one by one what are those demand paging. So what is pure demand paging? In the pure demand paging, what happened? We assume in the pure demand paging that my RAM or my main memory or my physical memory is empty, or there is nothing into that particular main memory. There is nothing into that, and whenever we require the page, we put here one by one whenever required the page, right? Now what happened into the prefetch demand paging? In the prefetch demand paging, there are some pages available into the main memory, or into the physical memory or into the RAM. There are pages available, and whenever we required more pages, we put here. Okay, this is pure demand paging and this is prefetch demand paging. in your examination or the problem when we solve it, it will take the pure demand paging type of concept in which every frame is free. Every frame is free. So this is all about your virtual memory, demand paging, and page fault. Next, we'll see different page replacement algorithm, and we'll try to solve those problems related to page replacement algorithms.